Section 4.4, using congruent triangles. We know from previous sections that we have the ability to prove triangles congruent, and we can do that by postulates and theorems such as side, 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 angle, side, angle, and angle, angle, side. What we can do then is to use this definition, which is corresponding parts of congruent triangles are congruent. We abbreviate that CPCTC. Again, that stands for corresponding parts of congruent triangles are congruent. To use that, we need to first prove that the triangles are congruent, and then we can prove that angles and segments of those triangles are also congruent. As we've learned before, if I can prove triangle A, B, C congruent to triangle D, E, F, I know that I have 6 correspondencies. I know that I have 3 sets of sides that are congruent and 3 sets of angles that are congruent. At this point, we can prove triangles congruent by knowing 3 segments, or 2 angles and a segment, or 2 sides and an angle. But what we want to do is still be able to state all the other congruencies or correspondencies within the triangles. And to do that, we use CPCTC. So just because I have angle A congruent to angle D, segment AC congruent to segment DF, and segment AB congruent to segment DE, I know that the triangles are congruent by side, angle, side. I gave you that information. Now what I want to do is to prove the other 2 angles in each triangle are corresponding and congruent, and I want to prove the remaining segment in each triangle are corresponding and congruent. And again, to do that, we use CPCTC. Corresponding parts of congruent triangles are congruent. To use the previous definition, I need to still prove that triangles are congruent. So let's take a look at a quick review session of proving triangles congruent by one of the postulates or theorems we've used in the past section. So here, we want to determine if the triangles are congruent, and if so, state the reason for the congruency. So on this first diagram, I'm given 2 segments that are congruent. What I can do is realize that the segment in between the 2 triangles are joined, and I can call that the reflexive property. And now what I have is the top triangle congruent to the bottom triangle by side, side, side. The next set of triangles, I'm given a double arc in the top triangle and the bottom one, and the bottom one has a single arc and the top one has a single arc, so I have 2 pairs of angles that are congruent. Again, by the reflexive property, the segment joining the 2 triangles together is congruent to itself by the reflexive property, and what this gives me is triangles that are congruent by angle, side, angle. The next pair of triangles, I have a double tick on the bottom and the top, and I have a triple tick on the triangle to the left and a triple tick to the triangle to the right. So I have sets of segments that are congruent. Now what I can do is create congruent angles here by the definition of vertical angles, and then I know vertical angle theorem that the angles are congruent. Therefore, these 2 triangles are congruent by side, angle, side. The next pair of triangles, I am given a segment in each triangle congruent and an angle at each triangle congruent. I have no other information that is available to me. I know that I require 3 different sets of sides or angles in some sort of combination to prove triangles congruent. I don't have that. Therefore, these triangles cannot be proven congruent, so they are not possible or not congruent. And our last step is going to give me an angle on the bottom one, congruent to an angle on the top one. I already have a segment that is congruent, and I can choose the reflexive property for the joining side. That would give me side, side, angle, but remember, that is not a valid reason for congruent triangles, and actually does not prove triangles congruent. Therefore, this also is not possible. My next example, we're given a proof. We're given that segment AD is congruent to segment DC. We're also given that segment BD bisects angle ADC. What we want to prove is that angle A is congruent to angle C. But from the previous definition, CPCTC, I must always have triangles congruent before I can get parts of triangles congruent. So my main goal is to work to congruent triangles, then use CPCTC to get parts of the triangles congruent and see if that solves my problem. So let's start with the given. We know that AD is congruent to DC. I can put tick marks in my diagram to represent that. Number two, I'm given that segment BD bisects angle ADC. Knowing that a segment or array that is a bisecting of an angle divides that angle into two congruent angles. So I know that angle ADB is congruent to angle CDB. And the reason? Definition of angle bisector. Step 3, the triangles are joined by segment DB. Therefore, I can state segment DB is congruent to segment DB by reflexive. Now, as stated at the beginning of the proof, I can state that triangles are congruent. Now I know I have triangle BDC congruent to triangle BDA. And the reason would be side, angle, side. Be very careful that we set up the correspondency correct. That in other words, the segments and the angles match up that are congruent. Now, I can prove that angle A is congruent to angle C because of CP, CT, C. Corresponding parts of congruent triangles are congruent. In our next example, I'm given that segment AB is parallel to DC and AD is parallel to BC, represented by arrows in our diagram. We want to prove that segment BC is congruent to AD. But recall, on these proofs, we need to prove that triangles are congruent first. Then I can prove segments or angles or corresponding parts of triangles congruent by CPCTC. So let's get to triangles congruent. Let's use the information that segment AB is parallel to DC. Those segments create alternate interior angles, and they are congruent because of the AIA theorem, and the lines are parallel. So angle ABD is congruent to angle CDB. I also know that AD is parallel to BC. They also create alternate interior angles, and they also are congruent because the lines are parallel. Therefore, angle CBD is congruent to angle ADB. The reason? For both, AIA theorem. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. Segment BD makes up both triangles. Therefore, segment BD is congruent to segment BD because of the reflexive property. Now, I can state that triangles are congruent. What I need to do is to make sure that they match up with corresponding parts. Therefore, I'm going to start with A, which has no arc, and I'm going to go from no arc to a single to a double arc. Therefore, triangle ABD is congruent to triangle, and I went from no arc to a single to a double, which would be triangle CDB. That justifies or clarifies the correspondence between the two triangles. The reason why they are congruent is because of the angle side angle theorem. And that is true because the segment is the included segment. With this statement, I can state that all angles and all sides are congruent within the triangle. But all I need to state is segment BC is congruent to segment AD. And the reason? CP, CT, C. Corresponding parts of congruent triangles are congruent. In the next example, I'm given that segment AD is a perpendicular bisector of segment BC. I also want to prove that segment AB is congruent to segment AC. Remember, we want to prove triangles are congruent first. So let's start with our given information. We know that segment AD is a perpendicular bisector of BC. If this is true, since it is a bisector of BC, I know point D must be the midpoint. Therefore, I know that segment BD is congruent to segment DC. And that is true because of definition of perpendicular bisector. Or I could say definition of midpoint because a perpendicular bisector intersects at the midpoint of a segment. Step 3. I know that AD is a perpendicular bisector of BC, therefore it forms right angles. And if that's true, then that means that angle ADB is congruent to angle ADC. And that's true because perpendicular lines form congruent adjacent angles. Or we could also use definition of perpendicular bisector. On step 4, I can state that AD is congruent to AD. Of course, that is because of the reflexive property. That will generate congruent triangles. Setting up the correct correspondency, I'm going to start with A going to the right angle. So triangle ADB is congruent to triangle, again starting with A going to the right angle, ADC. And that is true because of side, angle, side. Now I can state that segment AB is congruent to segment AC because of CP, CT, C. Corresponding parts of congruent triangles are congruent. Our last example, we have that segment VY and segment XW bisect each other. We want to prove that VW is parallel to segment XY. That is not part of CPCTC. That is another property. But we're going to follow the same procedure as we've had in the past here. What we're going to do is create congruent triangles, use CPCTC to generate some type of congruency that will help us prove that lines are parallel. So let's start with the given information. I know that segment VY and segment XW bisect each other. Therefore, point U must be the midpoint of each segment. So I can state that segment VU is congruent to segment UY. I also can say that segment WU is congruent to segment UX. And that would be because of definition of bisector. Or I could say definition of a midpoint because segment bisectors intersect at the midpoint of a segment. Step 3. I know that angle VUW and XUY are vertical angles. So I can state that angle VUW is congruent to angle XUY. And that is true because of the vertical angle theorem. Now, I can state the triangles are congruent. We need to get the correspondency correct, so I'm going to start at V and go to the single tick, single arc, double tick. So that gives me triangle VUW is congruent to triangle, and I went single tick to single arc to double tick, so that's going to give me YUX. And the triangles are congruent because of side, angle, side. I need to generate parallel lines, but to create parallel lines, I need congruent angles. I need VW parallel to XY. I can use two different angles. I'm going to use angle 1, which is angle W, and angle 2, which is angle X. So I can state angle W is congruent to angle X. I also can state angle V is congruent to angle Y by CPCTC. Corresponding parts of congruent triangles are congruent. Now that I have a set of alternate interior angles, I could have gotten two sets, but once I have one set of alternate interior angles congruent, then I know that the lines that form them must be parallel. So VW must be parallel to XY because of the converse of the AIA theorem. If alternate interior angles are congruent, then the two lines cut by a transversal must be parallel.